Hello, guys. Okay, so welcome to our lesson today. So today we are going to be learning about sketching a parabolic function. So that's what we're going to devote this lesson to. So by the end of this lesson, you must be able to produce a sketch of any parabolic function with much ease, you see. But before we begin, let's first understand what do we mean by a parabolic function. So a parabolic function, it is a function which takes this format, ax squared plus bx plus c. You see, so I think everyone is quite familiar with what we call a parabolic function. So it is a function which explicitly appears that way, where the a, b, and c's that you see here, so all these guys, a, b, and c that you see here, they all belongs to the set of real numbers, like that. So what we want now is to be able to produce a sketch or a plot of that function, you see. So before we produce a plot of that function, first we must uh, at least have some basic ideas as to like the graph of a parabolic function. How does it look when you are to produce it? Because at the end of the day, when you produce a plot, you must be able to verify that whatever you producing is reasonable true or not, you see. So that's why you at least you must have some general knowledge as to what is the geometrical structure of this function when you are to sketch it, you see. So a parabolic function, it can either have a structure which is which can either be one of these two shapes, you see. So at times a parabolic function can come out with a shape like that one, or sometimes you can come up with a shape like that one. So when a parabolic function is looking like the shape on the left, we say it is cup, you see. Sorry, it's not cupped, by the way, it's kept, meaning it is a cap shape, and then here it is a cup shape. So that's one of the things that can happen when you are plotting a parabolic function. You can either have its shape being cap shaped or cup shaped. But the question is, what determines the structure of the shape or the nature of the shape that you're going to get? So the nature of the shape that you're going to get is determined by this a, which is the coefficient of the quadratic term in the equation of the parabolic function, you see. So when a is less than 0, that is when a is negative, you must always expect the cap shape. And when a is greater than 0, you must always expect that kind of cup shape like that, you see. So when you are to plot a parabolic function, at least these are the expectations, that you must either get something which looks like on the left or which looks like something on the right. But it doesn't have to be positioned, as you can see here in the Cartesian plane. So it can lie anywhere in the Cartesian plane, but the shape, when you look at it, you must be able to say whether it's cap or it's a cup, you see, and that is determined by the A, as we have mentioned. So having this basic knowledge now, let's see how one can actually produce a curve sketch of a parabolic function. So let's look at a few examples. So an example that we're going to look at is as follows. So we're asked to sketch the function y is equal to 2x squared plus 9x minus 5. You see. So an understanding of the shape is not just all that you need in order for you to actually produce the plot. But immediately, one thing that we can deduce is that since we can see that the coefficient of the squared term here, a is greater than 0, this implies this thing is going to have a cup shape. So definitely we can see just by looking at the structure of the equation itself that whatever sketch that you are going to produce, it must have a cup shape because of A being positive there. But we need more information now to actually produce the plot. And the information that we usually need is where it crosses the X and the Y intercepts. So to answer this question now, this is how we proceed. You see. So first we'll start by determining where it crosses the Y-axis. And we do that by finding what happens to the function when x has the value 0. So when x has the value 0, we see the first two terms vanish and we get that y is negative 5. So which means this curve that I'm supposed to plot must be crossing at negative 5 in the y-axis. And to find where it crosses in the x, likewise, I say when y is 0, what happens? When y is 0, I have 2x squared plus 9x minus 5 equals to 0. So when y becomes 0, we see that the resulting equation is a quadratic equation, which can be solved using many different techniques, which mostly factorization, completing the square, and the formula. So first, what I'll try and do is to see if the factorization technique can work, because every time when the factorization technique can work, it is always the easiest method to use, you see. So I will go for that. So now to check if this thing does factorize, I will try and take first the first numbers and the last numbers and multiply them. So when I take the quotient of the quadratic term and the constant in a parabolic function and multiply them, I see that I get negative 10. Then the next question that I ask myself is, looking at this number that I have so far obtained here, I ask myself, do they exist two factors of this number such that when I add them together, they give me the number that is in the middle? That is 9 in this case. You see? So I start searching. So I know that there are many possible numbers that can give me 10 when I multiply. So there's 5 and 2, but 5 and 2 cannot produce a 9. Also, there's 1 and 10. So we see that 1 and 10 can produce a 9, and they can produce a 9 if 10 is positive and 1 is negative. So now when I find those two numbers which work, what I do now is I replace the middle number using those two. So this implies now what I have is 2x squared plus 10x minus x minus 5 is equals to 0. So now I have an expression that has 4 terms in it. And I know that every time when I have this, I try factorization by grouping. So what I do is I look at the common factor for the first two terms, and I see that 2x is common. And when I pull out 2x, what remains here is just an x, and what remains here is just a 5. Then here I see negative 1 is common, so I pull out a negative 1 and I get x plus 5 equals to 0. So if you understand the factorization by grouping very well, you would know that this has to happen all the time, that when you are factoring these two binomial expressions, you must get these two brackets always the same all the time, you see. So once they are the same, we pick one of them. So we take one of these x plus 5 brackets and we open another empty bracket. And in the empty bracket, we put the factors which lie outside like that. So now we know that if a product of two factors is 0, then either this is 0 or either the other factor is 0. So therefore, it follows from here that x can either be equal to minus 5 or x can either be equal to half. So which means now we have more information that we need to produce the sketch of our parabolic function. So now, how does it look then if we are to sketch it? So now to sketch the parabolic function, this is how it's going to be like. So I'll draw a Cartesian plane like that. And I label that. So make sure to label the axis all the time. And then after labeling the axis, now it's time to plot it. So we know that it has to be a cup. And looking at what we've managed to find, we see it has to cross the y at negative 5, which means it has to cross somewhere here at the bottom. And also, if you look at where it crosses the x-axis, it crosses one on the negative side and also on the positive side, which means just by thinking about what we have, we can see that definitely this function must look at something like that. So here, crossing at negative 5. Here again, crosses at negative 5. Here, crosses at half. Then you label your function to say this is y equals to 2x squared plus 9x minus 5. So yeah, this is how one goes about plotting parabolic function. Okay, so we'll end it here today. Thank you for watching. So if you like the video, you can please subscribe to my channel. Goodbye. See you.